All right, here we go. We are on 9-4, transforming quadratic functions. So do you guys remember when we were talking about linear functions, we talked about something that looked like that. What did I call that? That was the parent function, remember? And anything we did to that was a transformation of it. All the little kids, right? They moved up, down, left, right, etc. We have the same thing going on with a quadratic. So the parent function of a quadratic is f of x equals x squared. So my question for you is, what is the coefficient of x squared? Correct, 1. So what do you think happens to the parabola when the coefficient, when these are absolute values, by the way. So when we're just looking at the number, you know, that we're not taking in the sign into account, because remember, we've already dealt with the positive and negative signs, and I'll review that here shortly. But when you just look at the number before it, if it's bigger than 1, what happens? Well, first of all, before I even get to that, I want to draw a little picture here. So you have a parent function all nice on your paper. Let's see here. So go ahead and draw in. It's basically, it goes right through like that. The minimum point, 0, 0. It opens up. And it follows 1, 1, so the coordinates that it hits there are 1, 1 and negative 1, 1. So 1, 1 and negative 1, 1 are the coordinates that it touches. So what happens then when this is bigger than 1? Do you think this graph will get narrower or wider? Well, if you said wider, that's definitely the more intuitive answer, but it's not the correct one. Sorry. It's opposite of what your intuition would tell you. It actually gets narrower. And if it is less than 1, so like you have a 1/2 in here or something like that, it actually then gets wider than the parent function. Now let's refresh your memory. What happens when that coefficient is positive? What direction does it open up? Just like it is here, it opens up. And if we have a negative in front of it, then it opens down. So we're learning more and more things that we can tell by looking just at the equation. We can tell if it goes up or down, if it's more narrow than the parent or bigger than the parent. And so let's take a look at doing that. When I am going to give you in your homework different functions, so we got f of x and g of x, and I want you to order them. So order them from narrowest to widest. So of course the parts we are most concerned with is the number before it, and we want the absolute value of it. So the sign is irrelevant, right? So we're looking only at the 3, and we're looking at the 0.5. So which one has a number? Basically, the one that's the biggest is the narrowest. So which one do we want to write first? It says narrowest to the widest. So normally we'd think narrowest. Okay, we're going to take the smallest. No, you're going to take the biggest. It's the opposite of kind of what you naturally would think. So you just have to list them, and you don't have to list the whole equation. You can just put f of x, comma, and then the other one, which is g of x. So that is narrowest. And that is widest. Let's look at those 3. So again, we're looking at what part? Of course, there's the 1 there. We're looking at the 1. We're looking at the 1/2. And what are we looking at here? Just the 2, because the negative, remember, we have that absolute value up here. So we're always just looking at the positive version of it and ordering it that way. Biggest to smallest. When narrowest is the biggest. Widest is the smallest. So let's look at that. Which one is the biggest? Is it 1, a half, or 2? That's right. It's the 2. Even though it's negative, doesn't matter, because what does that negative tell you, class? Tells you it opens downward. The positive, that opens upward. Positive tells you it opens upward. We're talking about something different now. We're talking about the number, and it talks about how narrow or wide it is in comparison. So we took care of the 2. What's the next biggest? F of x with the 1, and then g of x is last place. And that will be the widest one. The actual fraction will be the widest one. Okay, so that's one part of your homework tonight, is you're going to order that. And my daughter's doing dishes in the background, which I am so grateful for. Thank you. But that's the clanking around you're hearing. So let's look at this next thing that you're going to do in your homework. Oh no, actually this is fun. If you take this, then not only do you know the y-intercept, just like we talked about, that c is the y-intercept, but it is also a vertical translation up or down on the y-axis. So when you see plus c, like here, plus 3, compared to a parent function, see there's no plus here, plus 3, that means that that parabola moved up 3 units. If there's nothing being added or subtracted, then its vertex is 0, 0. It doesn't go anywhere. Okay? So, now we're going to do some comparing. So just to be really clear, because I know sometimes when you see the word compare, it can feel kind of abstract, like you're not really sure what what I'm looking for there. I kind of lay it out like this with 4 points, and on a test or quiz I usually ask you, I think, 3. So you have your choice, but it should include things like, and let's write them down. Width. So we're going to look at this is compare the graph of each function with this graph. Okay, so everything is going back to f of x equals x squared, which is what function? The parent function. That's right. So we're trying to compare this to that. What happened to it? Okay, so let's look at the width. So what number in here is going to help me know the width? The 1. And what number in here is going to help me know the width? The 1/4. 1, 1/4. Which one's narrower or which one's wider? It doesn't matter which way you go, but you should say one of them is wider than the other, or one of them is narrower than the other. So let's just look at it this way. Is this going to be wider than this, or is this going to be narrower than this? Right, wider. It's smaller than this, so it's going to be wider. So we would literally use the letters and say g of x is wider than f of x. Because if you are comparing two different graphs, you need to mention both graphs in here, right? What's another way you could have written that? F of x is narrower than g of x, right? That would have been fine as well. The next thing you're going to want to look at is up or down. So write these next to it. So when you're home tonight, you're seeing your little notes here to help you remember what you should put in these. Up or down. So we're talking about, do both graphs open up? Does one open up, one open down? Do they both open down? So we're trying to determine which going on there with that. So when we look here and we see this is a positive, that's the part we're concerned with there, positive. This one is a negative. So they are not going the same way. F of x is opening up, and g of x is opening down. So that's what you would literally list. G of x opens down, f of x opens up. Okay, if they both were negative, you just say g of x and f of x open, did I just say negative? Down, and if they're both positive, you say g of x and f of x both open up. That's it. Another thought you can do is you can talk about their axis of symmetries. So axis of symmetry, you can see what's the same there. So when you're looking at the axis of symmetry, remember x equals opposite of b over 2a. So when we look at this, what's the axis of symmetry here? There's no b, so it's 0 over 2. So it's 0. So the axis of symmetry here is 0. The axis of symmetry here is, again, there's no b, so it's 0. So they both have the axis of symmetry being 0. So you could write that. Both have axis of symmetry x equals 0. All right, and the last thing you can look at is the vertex. That's another option you can do. So you can tell me what the vertexes of each of them are. So like the vertex of our function here is going, it's the parent function, right? So you could say the vertex of f of x is 0, 0. And then you could tell me what is the vertex of g of x. Well, it's going to slide up 3, so it's going to be 0, 3. Now, I'm going to add a fifth one because I just noticed it's not on here. And I think this one's easier than the last two, and that is the translation. You can talk about that. There's nothing here. This is a translation up 3. So you can say g of x is 3 units up, a 3 units up translation of f of x. Oh, I'm not on the screen anymore. So that would be helpful and kind of easier to compare as well than maybe getting some of these other things. That should be easy, for sure pick that one should be easy, and that one should be easy. And these aren't hard, but just take a little more thought and work. Okay, so let's try another one. I want you to try and see how many of those you can do. Again, pause the video so that you can try them first. And then I'm just going to keep going though. So width, which one's wider? This is a 1 and this is a 3. The smaller one is wider, so it'd be this one. So f of x is wider than g of x. Now if you had it g of x is narrower than f of x, that's fine too. Let's talk about up and down. Positive, positive. What'd you guys write? I'm going to write both f of x and g of x open upward. I'm going to do the axis of symmetry. Well, it looks like they're both going to have the same axis of symmetry because there's no b term, there's no x term, I mean, so there's no b. So they're both going to be x equals 0. So both have axis of symmetry at x equals 0. And then The vertex, because there's no movement up or down, the vertex is also the same for both. So both have a vertex of what? 0, 0. And if you want to talk about the translation, there is no translation. So I probably wouldn't choose that one since nothing happened there, so you're not really telling me anything. I would pick 3 of those. All right, so we've got a couple other things to go through. More of a real life problem, which I know some of you enjoy, right? Especially all the words. Okay, so 2 identical softballs are dropped. The first is dropped from a height of 400 feet, and the second is dropped from a height of 324 feet. Write 2 height functions and compare their graphs. Okay, first of all, something that we need to take, because we need to get the height formula because of gravity. It's like gravity's, oh god, I'm pulling, I think it's 16 meters. I'm not going to say it because I'm going to say it wrong. But here is the formula for height. -16. So I want you to write that down because you're going to need that. Maybe even highlight that or something. Okay? So let's think about this now. Remember, this represents the what? That represents the y-intercept, right? So the first is dropped from a height of 400. Okay, so it's going to be, let's just say each of these are 100. 100, 200, 300. Let's see. So there's 400 right there. And then the other one's going to be dropped from a height of 324. So that's going to be 100, 200, 300. It's going to be about right there. So I'm just kind of estimating just to get an idea with the graph here. But we're going to plug those values in because those are our y-intercepts. Okay, so it says write 2 height functions and compare their graphs. Okay, so let's write them out. So h of t equals, and it's going to follow again this format. That's why you needed that. 6t squared, and then plus the intercept, which we said was the 400. And then this one's going to be h of t equals -16t squared plus that one, which is 324. So when we compare them, what are you noticing about the y-intercept? Right, the y-intercept is, how much is that? 76 feet above on the first graph. Now we're supposed to use these graphs to determine when the softball reaches the ground. Okay, so we drop it out, we drop it up, it's going to hit the ground, and we're trying to determine when it hits the ground. Okay, because this is my time, this is my height, right here, and this is my time. This is my height, and this is my time. So we're trying to see when does it hit, because that'll tell me how long it took for the 400 one to hit and how long it took for the one that was only up 324 to hit. Okay, so the best way you're going to want to do that is when you, what is the time here? The time at this point, I mean the height, not the time. We're looking for the time. The height when it hits down is what? 0. So when h is 0, that's what we're trying to find out, when the height is 0. So we are going to find the zeros for each equation. So let's go over to this side first. Let's slide this up a little bit. So in other words, we're going to take and we're going to substitute 0 in for that and see what we get. Okay, so if you solve this, obviously move the 16t squared over to the other side. Divide by 16. 25, take square root, and t is 5. What unit are we using? Seconds. There it is up on the top. I found it. So that one took 5 seconds to hit. Okay. So 1, 2, 3, 4, 5. So there's your parabola coming into play right there. And then now, over here, we're going to do the same thing. 0 equals negative 16t squared plus 324. Move the 16t squared to the other side. Divide by 16. T squared equals 20.25. And t is equal to 4.5 seconds. Okay, so 4.5. So 4.5. That's about right here. So we're going to get somewhat of a more narrow. Well, actually, it's just lower. Yeah, so that's kind of cool. So you can figure that all out, all using different quadratics. Just remember, you understanding, well, this is something that's the gravity piece oops. That's the gravity piece that you wouldn't have known going into this. But this is the equation for height, and so knowing that where you're dropping it from, and then ground zero, where the height is 0, you can calculate how long things will take. So it's kind of cool. And just to be specific with that formula, I wrote this down, and this I got right out of the book, so you could look it up too. But it says it's used to approximate the height h in feet above the ground of a falling object t seconds after it is dropped from a height of the falling object. So there you go. All right, we'll see you tomorrow.